Let's solve the one question where we use stalling in the operand forwarding. Okay, let's solve this question using stalling first. Stalling. Before solving the question, remember three things which I told in the previous video. The first one is the arbitrary value is always we get from the right back. No same stage is occurred in the same clock cycle. We cannot take the wrong value at the beginning during the stalling. Okay, let's solve by remembering these 3 points in the mind. There is no any instruction before that, so simply if id ex me wb. Again load R3 in R4. Is there any dependency? No dependency. Simply if id ex me that wb. Add what? R3 and R4 and stored in R5. Is there any dependency? No, because this R3 and R4 is not dependent with any previous instructions. Simply if id ex me and wb. Okay, st means store. I told you in the automatic the value is stored in the left, and the load and the store the value is stored in the right. It means the value of R5 is stored in the R6. Is R5 is dependent with any previous instruction? Yes, this R5 is dependent with this R5. When this R5 operated value, then only we store the operated value in the R6, and we know in the stalling we get the operated value in the right back. It means instruction 1, instruction 2, instruction 3. We get the value of R5 here. Okay, so for phase we cannot take the wrong value at the beginning, so we have to put stop stalling, then we can get the value of updated value R5 here, so put decode, take the value, then ex mem and wb. And I told you we cannot start fetching from here because here is stalling and below stalling there is stalling, so you have to put stalling, then start from here if. Okay, load R7 into R8. Is R7 is dependent? No, if id ex me and wb. Okay, then load R9 R10. Is R9 is dependent? No, if id ex me wb. Subtract R11 R7 R9. It means subtract R7 now R9 and store in R11. Is R7 and R9 is dependent? No, because in the load this value is stored, not this value is updated, so no. Put if id ex me wb. Okay, and same store R11 into R12. It means this R11 is dependent with this. Okay, and we know that we get the value of R11 from where? From this R11 we get here. So fetching can take the wrong value at the beginning, so stop, then you can get id ex me wb. Then clock cycle 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Total clock cycle 16 with stalling. Let's see by using operand forwarding. This first two instructions is not any interlinked or there is no any dependency, so just simply draw the figure if id ex me wb. For second if id ex me wb. Okay, third add R3 and R4 stored in the R5. Is and their dependency? No, There is no dependency. Simply put, if id ex me wb. See, store the value of r5 into the r6. It means what? We will get the value of r5 from where? From the instruction 3 after execution. Okay, it means instruction 3 after execution. Okay, see, if, okay, then I take the wrong value first, id, because I will get the value of r5 from where? From where? From after execution. Okay, it means id, and before execution the value is operated, so ex me wb. No need of installing here. Okay, and what is second? Store r7 r, it and dependency, no dependency. If id ex me wb. Okay, 1 2 3 4 5. So 1 2 3 4 5 is done. Okay, load r9, load, no dependency. If id ex me wb. 1 2 3 4 5 6. 1 2 3 4 5 6. Second is r7 r9. Okay, is there any dependency? No dependency. If id ex me wb. Here r11, yes, the dependency. From where I can get this? From the execution part. It means if I take the wrong value before execution, I will get the value from r11 from there. So ex me wb. Then 1 2 3 4 5 6 7 8 9 10 11 12. Total clock cycle is equals to 12. If there is case come like that, let's see one example where we have to use operand forwarding, installing in the operand forwarding. Like one questions. Just here, let's solve one question. Okay, okay. If the question is like that, instruction phase id ex mem and wb. Okay, if the question is like that, store the value of r1 into r3, then add the value of r2 and r3 and store in r4. Let's see this example. Then I will tell you how you put the installing the operand forwarding. First, I have stored the value of r1 into r2. Okay, it means this r2 is dependent with this, and I told you in the operand forwarding the value of automatic operation will get from the where? After executions. But in the load and store we will get the value of operative value from the memory. It means first I am fetching. Okay, first I have take wrong value id because r2 is operated where? After memory. Okay, let's see, if I put execution here, it means what? It means r2 is not operated. I told you before execution we have to update the value, but I will get a value of operated value after mem. But if I do execution here, it means I will get wrong value. So I put installing here, and then execution here. It means I will get operated value of r2 here, and then execution there, then mem, then wb. Clear? See that if id ex mem wb. The value of r2 is taken from this. So if id wrong value is taken, but before execution I need the operative value, but operative value is getting from here, so I cannot do execution before the getting the value. So stalling execution, and then I put new value, then write back. Okay, in this case we have to use stalling in the operand forwarding. In the next video I am going to solve the most important topic of stalling in the operand forwarding, where we will get the condition like branch and jump, and maybe in the mid-semester exam you will get like branch statement or the jump statement shared. So be tuned for the next video. I will solve the most important and the mid-semester exam questions in the upcoming videos. So please be tuned. Thank you.